guys, that electrolysis of some electrolytes, all you want to read about electrolysis in this stage in order to know which one is going to be for the cathode and which one will be to the other. Okay? So first of all, the first substance here is NaCl, liquid, or you can say this is molten. You know, it's a solid, basically it's solid, so now because it's molten, so it's a liquid. So first of all, what are the ions existing here through this electrolyte? It's rotates Na+, and also we have, this is Cl chloride minus. So they are the ions we have, and of course they are liquid because it's molten substance. Okay, so for the ion section here we have two species or two different kinds of ions. What about what will happen at the cathode? Actually, guys, remember, sorry, this is anode, positive electron. You know, guys, that unlike charges attract each other. So because anode is positive, what do you think, guys? What kind of ions now will be attracted to this ion? Yes,
Chloride.
of course, this will be chloride. Because chloride carries negative charge, so it's likely to be oxidized by losing this extra electrode at the end. This electron, guys, is going to be lost, and of course, because chlorine is diatomic gas, so of course we need two. So what happens here, we say Cl negative liquid is oxidized, forming chlorine gas according to the following half equations. We need also, guys, we need to focus on the half equations. So we need actually two Cl negative liquid. We need two because again chlorine is diatomic. So we show here we have 7 diatomic gases, and also plus bromine is so every chlorine ion will lose 1 electron. So because they are 2, so finally they will lose 2. So basically here we have 2 lost electrons plus here we have Cl2 gas. So finally we will see bubbles of chlorine gas at the anode. Okay? And then what's going to be at the cathode, the negative electrode, and remember this is the battery, and here is the cathode, the one connected to the negative, and here this is the anode, the one connected to the positive. Okay? So guys, how many electrons do we have here? 2. So actually we need 2 sodium ions to gain these 2 electrons. So actually here we have 2. So first of all, this is, we can say Na plus liquid is reduced at the cathode. And now the half equation is going to be, so 2Na plus 2 electrons to produce 2Na. It's liquid first of all, and then it's going to be solid. Second one, take it as we have a difference between in case of it's molten, now in case it's aqueous. Can you tell me what is the best, what is the difference here in case of aqueous and molten? This one?
When it's in aqueous, basically it has there's another substance that's used, which is water or H2O, or there's sometimes used other
Yeah, exactly. So here, thank you so much. So now the pieces will not be chlorine and chloride and sodium only. We have also H plus and OH of water. So we have Na plus, and this is now aqueous. We have Cl minus aqueous. We have H plus aqueous, and we have OH negative aqueous. Actually, here we have 4 species because we have water molecules plus sodium chloride molecules. Okay? Take it, guys. Here we have 2 different cases. In case of here refers to this is concentrated solution, and here this is diluted solution. So both of them have the same ions. So I can repeat same ions here, the same in diluted, to show what is the difference between them. So here we have Cl minus AQ, H plus AQ, and here we have OH minus AQ. So right now, guys, in case of concentrated aqueous solution of NaCl, and in case of diluted solution of NaCl, right now we have the same species. Okay? Let's see what's going to be at the anode and what's going to be at the cathode. Actually, there's a difference between concentrated and diluted because here we have Cl amides. Remember, Cl is called a halide. Cl amide here is called a halide. Halide here means, guys, the negative amine of halogen. Remember halogen group 7 in the periodic table, or you can say 17, start above with fluorine, bromine, iodine. When they form amines, guys, it's called the amines of halogens. It's called halide. So in case if you have a halide, so halide here we refer to actually F minus, or we have Cl minus, or Pr minus, or R minus. In case of a halide, we will have a difference between the concentrated solution and diluted solution. Take care, this is only in case of the halides. Otherwise, the rest of amines, it doesn't matter. Okay?
Mister, what if it's concentrated and diluted in a halide?
Yeah, we'll see now. We'll see now what the difference between concentrated and diluted in case of amines. Let's start by concept. What's going to be at note the positive one. See, guys, this is positive. And here we have two negative species, fluoride and hydroxide. Question is, which one is more likely to be oxidized at the anode in case of concentrated chemistry? Is it Cl or OH? Yes.
OH.
No, I'm so sorry. In this case, it's going to be Cl. Why? Here, guys, we have very important rule. In case of the presence of any halide, if this halide is concentrated, so the halide ion is more likely to be oxidized at the anode. So Cl is going to be oxidized rather than OH. Why? Because it's concentrated. And it will happen the same with bromine or with bromide, with iodides, or halides. Will be the same in case of concentration. So we can say Cl negative AQ is oxidized. What about the half equation? The half equation will be the same like this one. So we have 2 Cl negative, but this is aqueous. So it will lose 2 electrons plus chlorine gas, will carbon. This is a half equation for chlorine that happens at. So what about the positive? In case of positive here we have Na and H. Na and H, two different species. Which one is more likely to be reduced at the cathode? Is it hydrogen? Is it sodium? What is the rule we have here? Yes.
I think that hydrogen will form at the cathode. That's because it's less reactive than sodium. The reactive.
Yeah, thank you so much, ma'am. So the rule here, guys, the rule which is used all the time, that at the cathode it's only one rule. Take care of one rule. Whatever the solution is concentrated or diluted. We have only one rule, guys, at the cathode. What is the rule, guys? This is the less reactive ion is more likely to be reduced than the less reactive. How do you know the less reactive and the most reactive? Exactly. Actually, we need to memorize the chemical activity series. You have to memorize this series to help you to know which one, or to determine which one is less reactive, which one is more reactive. Okay? So here, in case of Na and H, H plus will be reduced at the cathode. And then what will happen for Na plus? Actually, they will stay or remain within the electrolyte, within the solution. Okay? So what is if H plus AQ is reduced? And half equation, take care here, we have 2 electrons, and hydrogen is diatomic as well. So 2H plus AQ plus 2 electrons, so it will gain this 2 electron lost by chlorine, 2,4 hydrogen gas, H2 gas. And this H2 gas will start to go at the cathode after the reduction process. Okay? So here is the difference in case of diluted. Take care, this is the same, the electrolyte, but aqueous. But this is concentrated, this is diluted. The only one difference here, guys, here at the end. Here we have the same competition between Cl and OH. But now OH wins. See why? Because this solution is diluted. So OH is more likely to be oxidized at the anode. Okay? Not Cl. So the first one here we say OH minus AQ is oxidized. This is the only one difference between case of concentrated and diluted with halide. Only halide, I repeat, this is only halide. Okay? So what about the half equation of hydroxide? Actually, the half equation now, because it will produce oxygen gas. Oxygen gas will be reduced now. You know, oxygen is O2, so it's composed of 2 atoms of oxygen. Every atom carries 2, in case of an ion, carries 2 charges. So every one will lose 2 charge, plus 2 charges second one. So finally, oxygen O2, in case of ions, it will lose 4 electrons to be oxidized. Okay? So we need actually here 4 OH minus AQ. So they will lose 4 electrons plus. So 2 water molecules will be produced, 2 H2O liquid, plus this is oxygen gas reduced. Just take care here is the basic difference between concentrated and diluted. In case of concentrated NaCl aqueous, chlorine gas will be produced at yellow. In case of diluted, not chlorine, it's going to be oxygen. I think it's a very big difference. We should focus here. What happens at the cathode is the same, no change. So I do the same like this. So it means this is the same as that. So actually, the only one difference between being concentrated or diluted aqueous solution of any halide, again, this is from any halide, whether it's fluoride, bromide, like the same. Okay. Now let's do 2 other examples. But here you see the amine is sulfate, SO4, and here the amine is nitrate, NO3. Guys, I have a question. Is it halide? SO4, is it halide? Halide means FClBr. Is it halide?
No.
No. What about NO3 acid? Is it halide? No, it's not halide. So in case of this is not halide, so we don't have any rule. In case of no halide, so we have only one rule. What is this rule, guys? In case of halide, actually OH minus will be oxidized all the time. It doesn't matter is it concentrated or diluted. So what are the species here, guys, or the ions? Actually here we have Cu2 plus AQ. We have SO4 2 minus AQ, H plus AQ, OH minus AQ. 4 species. That's it. Here Cu and H. Which one is going to be reduced and then Cu or which one is this reactive gas? If you remember the arrangement of the chemicals. Yes,
Hydrogen and
hydrogen is this reactive then copper? Not really. Actually, it's a copper, so you forgot the chemical activity. Copper guys is reactive than hydrogen. So this is copper, it's more like. What about SO4 and OH here, guys? We said before SO4 is not halide, so the rule now is OH. OH. So we can do the same for OH here, guys. So OH minus AQ is oxidized, and the same half equation, guys, for OH minus AQ. And again, why it's 4? Because again, O2 will produce 1 oxygen molecule. Oxygen molecule is composed of 2 oxygen atoms. Every atom in case of iron carries 2 charges, 2 times 2 R. Okay, so 4 OH will produce 4 electrons, 2 water molecules, plus oxygen gas, and this is. What about the reduction? So Cu or H? Why? Because Cu is less reactive than H. So here we have, here we have 4 electrons, 4 electrons. So we need 2 Cu, 2 plus 8 plus 4 electrons to reduce to Cu solid, and this is, you know, this is red color. And so what happens here, we say Cu2 plus AQ is reduced. I think the rule is very obvious. What about the last case? This is silver nitrate. See, guys, concentrated or diluted, it doesn't matter. Why it doesn't matter? Because no halide. Once no halide, so it doesn't matter. Concentrated and diluted is. So here, what about the species we have? So here we have Ag plus AQ, we have NO3 minus AQ, we have H plus AQ, and we have OH minus AQ. Okay, here we have NO3 and OH. Which one is more likely to be oxidized? Is it NO3 or OH? Yes?
I think it's OH.
OH because no halide. These are all guys. Because no halide, so it's OH. So we can do the same here, guys, like this one. We can copy the same result and the same half equation for the OH. What about AG and H? Which one is less reactive, guys? Which one is more likely to be reduced? AG. Exactly. AG is below hydrogen. So, and because here, remember, we have 4 electrons like this. So we have 4 Ag plus AQ plus 4 electrons to form 4 Ag solid. This is silver color. And we say here Ag aqueous is reduced. Okay, guys? So you can use this as a reference for all electrolytes. In case if you have a halide, focus, is it molten, aqueous concentrated, or aqueous liquid? You can do the same. If you don't have a halide, so in this case, all the time my drop sign ions will be oxidized rather than the other amine, whatever. Hopefully it was clear.